that it calls XXX user power callout worker. Okay, where is that? Let me, no, that's not, no, it's not that. Okay, something's, let's find it. Okay, yeah, here it is. Okay. It doesn't unqueue, okay. Does it check and call something else? User power event callout worker. Okay. And here it says switch. Okay, our case, remember it's number 2. So it's probably that one. Power policy change. It does the system parameters info. Set low power timeout and set power off timeout. Well, what's that? Well, here it is, system function, and here are the specific cases. Okay, now again we have some global variables that probably are getting set. Okay, here is a go-to statement, handles the writing. Exactly. It goes and writes into these global variables. Okay, these variables have the millisecond timeout for the monitor turn off. Okay, now the question is who accesses these variables. So I'm gonna see through SoftICE. Let's set a memory breakpoint. Let's see. Okay, it's spaced out. No problem though. I'm going to set a breakpoint there. Breakpoint set a hit within a second. Okay, here it is. It's a function idle timer proc. When the system is idle, these variables are getting checked. Let's see where this is defined. Input.c. Input.c, here it is, idle timer proc. And what it does. Okay, we see that it does a check for the screensaver and probably launch the screensaver, and then it does a check for the lower power and power off conditions. Okay, how does it check if it's time to do that? Okay, it's a function is time from last input defined here in line. Okay, gets the current tick count, subtract something, and check if it's greater. What's that? That's a structure, a global variable tag last input. Okay. And then how does it trigger power off? With a post message. Sys command monitor power. Okay, let's see that. Sys command. Okay, it's here, defined here. And here's the specific case. Which, okay, we see that probably sends something to the driver, video card driver. And that's the end of the trace. We can't go any further. We don't need to go any further. Okay, now, things are now, what happens right now? Many things. A wild guess probably would like to monitor the GLIMP structure. It turns out that it gets reset every minute, and that was the problem. Okay, that was not straightforward to find. It needed a lot of trial and error, but finally that was it. Let's set a breakpoint, memory breakpoint there, to see who triggers the change in this global variable. Okay, it's a little tricky because, okay, let's wait actually 1 minute. Okay, here we go. Okay, let's see, it's more tricky than we can think of, because the this variable gets written exactly when we exit the SoftICE. So we have to set a conditional here. Okay. Otherwise, we won't see the actual cause of this change. Okay. Okay. Here we fast forward. Actually, it's 1 minute. Takes 1 minute to get written. Okay, here it is. You can see ET 60 seconds. Okay, let's see who did that. Okay, we are in the stack tracing, the kernel stack. We've gone back to user mode, and we can see that winlogon run screensaver. That's the one that triggers a refresh to the G last input structure. Okay, back to IDA Pro, we can see run screensaver is here. It's in the winlogon XN. What it does is probably launches the screensaver, but we can see here that it asks for information. Okay, here, and then validates the screensaver. If something goes wrong, it does a reset. Okay, it asks if the screensaver is active, and then takes the screensaver timeout and sets it again. Okay, probably just refreshes it. Okay, and why this action causes a last input refresh? Let's see. Let's go here. Okay, here it is the set screensaver timeout, which, as we can see, exactly, it refreshes the last input message. So that's it. The screensaver tries to go on to fire, but something goes wrong because there is no screensaver. At every 1 minute, this thing happens, and the last input is reset. So this timeout will never reach 3 minutes, for example, in order to turn off our monitor. But okay, who and what happens? We can see here that the screensaver timeout is positive, which means that the screensaver is active, but that can't be. We can see that nobody can reset that. If it's negative, it remains negative. So something nasty happens here. Somebody is doing something nasty and manages to negate the value, make it positive again without any screensaver set. Okay, let's click on OK here. So, and we will verify now that the value is negative again. Okay, no screensaver set. Who did this change? Who changed this value from negative to positive and caused all this trouble? We are going to put a screensaver there, a memory breakpoint, and because I know what happened, let's go and watch a Flash video. YouTube, Google I/O video. Okay, loading. Here it is. It will start playing in a few moments, and you will see that somebody changed the screensaver timeout. Who is he? Let's go back in the stack, go to user mode, and we see GCSWF, which is the Adobe Flash Player plugin. That was it. Adobe Flash Player plugin is responsible. It resets the screensaver timeout and causes all this trouble, disables the turning off the monitor.